So today we will be looking at a special type of linear relationship called a proportional relationship or a direct variation. A direct variation is just a special type of linear equation that thinks it's better than all the other equations. And the reason why it thinks it's better than all the other equations is because it's very simple. It goes through the origin. An example in real life of a direct variation would be if you go to the movie theater and you buy tickets that are $10 each, and you buy 5 tickets, it would cost you $50. If you bought 8 tickets, it would cost you $80. All you're doing is multiplying by the cost of the ticket, and that's your total cost. On the other hand, if you decide to buy your tickets ahead of time online, you pay $10 per ticket, but then you also pay a fee for purchasing your tickets online. So if you buy 5 tickets, it might cost you $53. If you buy 8 tickets, it might cost you $83. There's an extra amount associated with this equation, and that makes it not proportional. So to be proportional, it has to have nothing extra. You're just multiplying by your slope. And so a direct variation is special because its y-intercept is 0, which makes it proportional. Direct variation equations are just in the form of y equals mx. There's no b. The b has to be 0. Some say that instead of using y equals mx, you'll see in some books y equals ax. Last year, you may have said y equals kx. They all mean exactly the same thing. In a direct variation, the slope also has another special name. It can't just be slope because it's so special. Another name for it is the constant of variation. And in math, we use the letter K for constant of variation, and that's why you may have said y equals kx last year. So today, you're going to learn how to pick out this special proportional relationship or direct variation from a graph, from an equation, from a table. And then you're going to learn how to write a direct variation. From a graph, it's very simple. It has to be a straight line, and it has to go through the origin. If it's a straight line and it goes through the origin, then it is proportional or a direct variation. So this first graph here is a direct variation because it's a line and it goes through our origin. If you're asked to give the k, that's another name for slope. So you're just being asked to find the slope. On this graph, you want to be careful because if I pick this point and this point to find my slope of, I'm going up 1 block and over 1 block, but my blocks on my y-axis each are 3. So I'm actually going up 3 over 1, up 3 over 1, up 3 over 1. So you need to be careful of scale when you're finding slope from a graph. This second graph is not a direct variation because it does not go through the origin. So we would not consider the slope k or a constant of variation because there is no direct variation. From an equation, you have to have an x and a y in the equation, but you can't have any extra numbers because the y-intercept has to be 0. So if I look at this first equation, there's a 12 here, which means that if I rewrote this to y equals, I would have an extra number, and that would be my y-intercept. So this is not a direct variation. This next one, if I rewrote it, I would send over the negative 5x as positive 5x. So I'd have 2y equals 5x, and then I would divide both sides by 2. So I would end up with y equals 5 over 2x. There is no extra number being added or subtracted to make this equation work. So it is a direct variation. And the k is 5 over 2 because that's my slope.